Hey guys, hope you guys are doing well. This is my first trial run for a video. Hopefully this goes well. Um, Monday and Tuesday we're going to do Pythagorean Theorem on page 461, and I thought I would just go through the odds with you guys. So this is considered a 2-day assignment. Hopefully you guys can see the board well. I'm up here at the school. Pythagorean theorem works with right triangles. Its relationship between three sides of right triangles is always the same. It's always a squared plus b squared equals c squared. You guys probably remember this a little bit, at least from 7th or 8th grade. We've done it before, so hopefully it comes back to your memory. So I'm just going to start going through the odds here in a second. A, B, and C stand for the three sides of a right triangle. A and B, we call those sides the legs. They're around the right angle. And then the longest side we call C, and it's called the hypotenuse, and it's always across from the right angle. So anytime you have a right triangle, the relationship between the three sides is a squared plus b squared equals c squared. So on number 1 on page 491, they give us a and b are 3 and 4, and we're supposed to find c. So I'm just going to plug that in, 3, 4, c. So to find c, I'm going to use this formula right here. 3 squared plus 4 squared equals c squared. 3 squared, 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25. So 25 is c squared. So this means something times itself equals 25. So what squared equals 25? 5. That's right, kids. I feel like I'm on a kid's show here. So technically, negative 5 times negative 5 is also 25, but negatives don't make sense on these problems. We're just going to use positive 5. Another way to think about it is if c squared is 25, you take the square root of both sides. That turns into a normal c, and number 1, c equals 5. The end. Okay. Number 3, same thing. This one's not going to be as pretty though. Number 3 says a and b are 4 and 5. So we got 4 squared plus 5 squared equals c squared. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 16 plus 25 is 41. That's right. C squared. Okay, this one's a little different because what squared equals 41? Well, nothing nice. It's something, if you plug it in your calculator, you get a weird decimal. It's a weird number, so instead of writing the weird number, we're just going to write, well, whatever the square root of 41 is the answer. I don't want the decimal. The book doesn't want the decimal. We're just going to put square root of 41. It doesn't simplify nice like the last problem, so we're just going to leave it like that. The end. Okay, number 5 is different because they give us the a and c value, not the b value. So they say a is 2, c is 8. So 2 squared plus b squared equals 8 squared. Okay, 2 squared, 2 times 2 is 4. 8 times 8 is 64. Okay, got a little equation, get b by itself. So I need to subtract the 4. B squared is 60. All right, so you take the square root of both sides. B is the square root of 60. Unfortunately, on this one, the square root of 60 is going to be able to simplify. So we need to go back and do that. Some of you might have Casio calculators that can automatically simplify a square root of 60. The rest of us will have to struggle through here. So hopefully you did this last week, but the way you simplify a square root is with the tree. Looks like we might not be able to see it, so I'm going to move it up over here. 60. What goes into 60? There's a bunch of things, but there's one of them. 3 times 20. What goes into 20? 5 times 4. What goes into 4? 2 times 2. All these bottom numbers are primes. Those branches stop. So 2 times 2, the doubles go in the front. 2 times 2 is 4. And then the leftovers are 5 and 3. 5 times 3 is 15. Okay, so square root of 60 is the same thing as square root of 4 times square root of 15. The reason we do that is because doubles always have a square root. What times what equals 4? Well, 2 times 2 does. So square root of 4 becomes normal 2. Square root of 15 stays the same. So number 5 is 2 square root of 15. Any questions? Understood it perfectly? Wonderful. Beautiful. This is a lot easier. Plus, when I'm looking out, I'm just looking at myself the whole time. So it's great. All right. Number 7 gives us, it's kind of like number 5. It gives us B and C, not A. So it'll be A squared plus 7 squared equals 9 squared. Did not give us the A value, just gave us B and C. Okay, 7 times 7 is 49. 9 times 9 is 81. Get A by itself. (81 minus 49 is 32. I just realized I don't have a calculator handy. Might need that later. All right. So A is going to be whatever the square root of 32 is. Unfortunately, 32 doesn't have a square root, but it can be simplified. If I break it down, all right. 4 times 4, 2 times, oops, no it's not. 4 times 8, 4 times 2, 2. We have 5 2's. 2 times 2 times 2 times 2 times 2 times 2 equals 32. So what I'm going to do is take 4 of the 2's, 2 pairs of 2 makes 4 2's, and put that in front. 2 times 2 times 2 times 2. Put those pairs in front. That makes 16. And then there's 1 2 left over, so that's got to go in the back. So this just says 16 times 2 is 32, right? Square root of 16 times square root of 2 is 32. Now we put those doubles in front because they actually have a square root. Square root of 16 is 4. So this is 4 square root of 2. And that will be the final answer. All right, next section. It's not really anything new. A new kind of problem, not a new idea though. They're asking, are these right triangles, yes or no? We can tell because the Pythagorean theorem only works on right triangles. So if the Pythagorean doesn't work, we're going to say no, because it's not a right triangle. If it does work, we're going to say yes, it is a right triangle. So the legs on number 9 are 9 and 12, and the hypotenuse is 15. The hypotenuse has to be the biggest side, and it should always be across from the right angle. So does 9 squared plus 12 squared equal 15 squared? Question mark. Okay. The Pythagorean theorem says if it's a right triangle, it will work. Okay. So does this work? Yes or no? 9 squared plus 12 squared. And yeah, 81 plus, that is a true statement. So on number 9, put yes. The end. Number 11. Okay, it says 4, 6, and 8. Okay. does 4 squared plus 6 squared equal 8 squared? Question mark. 4 squared, 16. 6 squared, 36. 8 squared, 64. 16 plus 36 is, I think it's like 52. Nah, not equal. So number 11 would be no. Pythagorean theorem didn't work, so no, it is not a right triangle. 13 through 16, exactly the same thing. I don't know why they did they just didn't draw a picture for us. So on number 13, it says 10, 8, and 6. They didn't draw a picture, but 10 would have to, if 10 is a hypotenuse, it would have to be, or if there is a hypotenuse, 10 would have to be it because it is the biggest side. So basically we're asking, does 6 squared plus 8 squared equal 10 squared? Question mark. Okay, 6 squared is 36, 8 squared is 64, 10 squared is 100, 36 plus 64 is 100. That's a true statement, therefore it is a right triangle. Number 13 is yes. 15 has a trick. Your calculators, by the way, can handle this if you plug it in right. So 15 says 4 square root of 3 and 1. Well, what's bigger, 4 square root of 3? I know 1 isn't. Square root of 3 means what times what equals square root of 3? It's smaller than square root of 3. If you plug it in the calculator, you get like 1.7 or something, I don't know. But 4 has to be the biggest side on this one. So does 1 squared plus square root of 3 squared equal 4 squared? Question mark. If you plug in the calculator, you might be able to do it like this easy. To be careful, you might put parentheses around that square root of 3. I guess it probably won't matter either way, but if you're not sure you're plugging in right, usually parentheses help. Okay, 1 squared is 1 square root of 3 squared. That means square root of 3 times square root of 3, which equals square root of 9. What's square root of 9? Normal 3. Okay, square roots and squares are opposites. So they kind of cancel each other out. It's like dividing by 2, multiplying by 2, they cancel out. So really, when you do a square root squared, it'll always just become that normal number. 3 is not the same thing as square root of 3. Okay, square root of 3, like I said, is like 1.7, blah, 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 blah. Okay, 4 squared is 16. Does 1 plus 3 equal 16? No. So that was number, what was that? 15. So I see on 16 it says like 4 square root of 2, 3 square root of 2, and 5 square root of 2. 5 square root of 2 would have to be the biggest side. It'd have to be the hypotenuse. You could plug that in, like, for example, 3 square root of 2 squared. That's something you would probably want to use parentheses on in your calculator. Okay, you could do it without a calculator. Just square everything in the parentheses. 3 squared is 9 times square root of 2 squared. Remember, square and square cancel each other out, is just a normal 2. So this means 3 times square root of 2 squared, it becomes 3 times 3 is 9. That times that is 2, 18. Okay, calculator can't handle it. Anyway, that's just part of number 16. That's not the whole thing. Number 17 is totally different. This is kind of why I made it a 2-day assignment, because there's kind of a lot going on here. On 17, we're switching to find the midpoint of a segment. So what they're talking about is on a graph, you'll have a couple points between a line segment between a couple points. They're asking what's the location of the point that's directly in the middle. Okay, and basically how it works is this has an x and y coordinate, this has an x and y coordinate, this has an x and y coordinate. The x and y coordinate of the point in the middle is just going to be the average of the x coordinates and the average of the y coordinates. Kind of makes sense if you understand what average does. It just finds a number in the middle. Well, how do we find the average of two numbers? Well, if you're just using two numbers to find the average, you add them together and divide by 2. So this formula is probably written in your book and a bunch of different places, but this is called the midpoint formula. If you're taking notes, this would be something to write down. Whoops. Okay, that is how you find the x-coordinate. You add the two x-coordinates together, divide by 2. That gives you one number, which will be the x-coordinate of the midpoint. Okay, and then the y-coordinate looks just the same. You add the y values together, divide by 2, and that gives you the y-coordinate. Okay, so on number 17, it says 2, 4, and 6, 6. 2, 4 is the first point. 6, 6 is the second point. You don't need a graph to work this. Maybe I'll... Two, 4 might be somewhere around there, over 2 up 4. 6, 6 would be somewhere up there. So the midpoint will be like, somewhere in between those two. Okay? You don't need a graph to figure this out. You just need to average the x values and the y values. Okay, the x values are 2 and 6. The first value is the x values. Remember, alphabetical order, x before y. So the 2 and 6. So to find the x-coordinate, I'm going to do 2 plus 6 divided by 2. 2 plus 6 is 8, divided by 2 is 4. Yeah. Forget that, I'll write that later. The y values are 4 and 6. 4 plus 6 divided by 2. Okay, 2 plus 6 divided by 2 is 4. That's the x value. I'll put it over here. 4 plus 6 divided by 2 is 10. 10 divided by 2 is 5. So the midpoint is at 4 or 5. So you can imagine over here in my little graph, this might be at 4 or 5. That point might be about in the middle. All right, anyway, so 4 or 5 is the answer. The end. Okay, same thing on number 19. The only difference on this one is they put some negatives in there. So don't let the negatives scare you. All right. Says negative 5, 0, negative 10, negative 14. All right. So the x-coordinates are going to go in front. So I'm going to do negative 5 plus negative 10 divided by 2. Those are my x-coordinates. And then the y-coordinates go next. So it's 0 plus negative 14. Same thing as 0 minus 14 divided by 2. Negative 5 plus negative 10 is negative 15. Negative 15 divided by 2 is negative 7.5. I guess I'll write it over here again. I don't care about fractions or decimals. 0 minus 14 is negative 14. Divided by 2 is negative 7. So that would be our answer for number 19. Okay. That formula only applies for 17 through 19 because that's where they're asking for the midpoint. Once we get to 21, they're asking for something completely different, and that is the distance. Okay, so using my picture from earlier, if we want the distance between 2 points, like how long is that line from there to there if we measured it? What they're going to use is the Pythagorean Theorem, and that's why it's in this lesson. If you draw a line over and draw a line up, it makes a right triangle. And this length right here, I'll call it A, is just the difference in the x values for these 2 points. Like maybe this one's at, I forgot what I wrote, but 2 something. The x value for this point might be 2. X value for this point might be 6. So from here to here, from 2 to 6 is 4. And, the up and down line would be the difference in the y values. Okay, that'll be like our b. It'll be the difference in the y values. Once we have a and b, we can use the Pythagorean theorem to find c, the hypotenuse, which also happens to be the length of this little segment. I know this is kind of quick and it'd be probably better to interact at this point, but I'm going to go ahead and plow through. So we have a formula for this. If you didn't understand that, you can still do this because the formula it's called the distance formula. I'm going to erase that old one. Hopefully these markers are showing up. Yeah, let's erase all that. Nope. Should have tested the markers beforehand. That looks all right. All right, distance. Can I squeeze it over here? Let's put it, all right, kind of big. Okay. You subtract the x values and then square it. Okay, that gives you like the a value. Plus, subtract the y values and square it. That gives you like the up and down length. Add those together, take the square root. Okay, it's kind of a lot to keep track of, but we got this formula to help us. Remember, order of operations, parentheses is first, parentheses, exponents is next, and then we're going to add, and then all of that is under the square root. Some people like to forget that, but you need to take the square root at the very end, because everything under the square root has to be square rooted, not a real word. Okay. Anyway, so let's plug it in for number 21. It says 3, 4, and 0, 0. So the x values are what I want first, the first numbers in the ordered pair. So 3 is the first number in the first set of parentheses, and 0 is the first number in the second set. So those are going to go in for my x values. Okay, and then the second parentheses, I'm going to put my y values in, y minus y. Now it says x2 minus x1. I don't know why they put that. The order doesn't really matter. When you subtract things in opposite orders, you'll get the same value, but they'll be opposite. Like 8 minus 3 is 5, 3 minus 8 is negative 5. Okay, so that it does kind of matter, but when you square a number, whether it be positive, 5 squared is 25, negative 5 squared is also 25. So it doesn't really matter what order you put it in. You do need the x's to be up front, you do need the y's to be in the back, but it doesn't really matter which x you put in front of the other one. It's all going to come out the same. Okay, the y values were, 4 on the first parentheses and 0 on the second. All right, parentheses first. 3 minus 0 is 3. And I'm going to go ahead and square it to save some space. I don't want to write down every single little step. 3 minus 0 is 3. 3 squared, 3 times 3 is 9. I'm saving the plus for last, remember. 4 minus 0 is 4. 4 squared, 4 times 4 is 16. Okay, so what do I have left? I have the plus and I have the square root. Everything in the square root needs to be done first. It's kind of like everything in the square root's in parentheses. 9 plus 16 is 25. The square root of 25, what times itself equals 25? 5. Okay, so the length of that line between those 2 points is just 5 long. That's what that means. All right. Let's jump to 23. Same thing. The x values on 23 are 6 and -1. Okay, the negatives might fool us if we're not careful. Just going to keep our square root in there. So the x values are 6 and -1. So we do 6 minus -1. I probably better not put another parentheses. 6 minus -1. Okay, sometimes people forget there's a minus. Plus the y values are 0 and 1 on 23. So 0 minus 1. Okay, whoops, forgot my squared right there. 6 minus -1. That means 6 plus 1 is 7. 7 squared, 7 times 7 is 49. Okay, 0 minus 1 is -1. -1 squared is +1. Remember, the order doesn't matter because either way you're going to get a positive. So that's a +1. Okay, that's all still under the square root. 49 plus 1 is 50. Square root of 50. 50 does not have a square root. It's not 25. 25 times 25 is like 625. But it can simplify. There's a double inside of 50. And if you're not sure, you just got to kind of play with it and figure out if there is anything. 50 is 5 times, and if you don't simplify square root of 50, I'm going to like take half off, sorry. Anyway, 50 is 5 times 10, and 10 is 5 times 2. So there's a double 5 in 50. If it's got a double in it, it's going to simplify. I just realized you can't see that very well. Yep. Beautiful. Now, yeah. Okay. Anyway, so the doubles go in front. 5 times 5 is 25. The leftover is a 2. That's going to go in back. Square root of 2. Square root of 25 is 5. Square root of 2 doesn't simplify. So that's as much we can do. That's the answer to number 23. Okay, last one for me. And you guys have to do it on your own. 25. Okay, x values go in front. All right. All right. 25. I'm putting the x values in front. I see a -3 and a 2. So -3 minus 2 squared. Y values are going to go in back. What's it say? -1 minus -13. Yeah, don't use parentheses again. Second on there. All right. Okay, so -3 minus 2. Some of you would miss that without help of a calculator. That's down 3, down 2. It's all the way down to -5. -5 squared, though, is positive 25. -1 minus -13. Minus negative means plus. So -1, you're -1 in the whole. You go up 13, you're at positive 12. 12 squared, you guys remember your times tables? 144. 25 plus 144 is 169. Kind of good news. Does 169 simplify? Yeah, 169 is a perfect square. Means if you plug in your calculator, you just get a normal number. It's not in our times table, so you guys might not have known that. Anyway, plug that in your calculator, you're going to get 13, no matter what kind of calculator you got. So that is the number 25. All right, hopefully this gives you guys all you need, and if you need any help, feel free to email me. Good luck.